Wow, that's a lot of people. Hi, everyone. Thank you all for coming. I'm really happy to see this much people here. And yeah, I'm Roa, and today I want to talk to you about art. And yeah, so the year is 1968. A wave of unrest and protests is passing through the streets of Paris, while a pioneering artist is cooped up with an IBM mainframe computer, producing one of the earliest computer-generated generative art pieces in history, and creating a lasting impact in the field of the digital arts. Vera Molnar is a Hungarian artist based in France, who now in her 90s is still actually producing work and is as passionate about computer art as ever. From a young age, she was fascinated by randomness. She was one of the earliest adapters of using algorithms to create computer artwork, and in a time when computer-generated art was considered dehumanized and its authenticity highly doubted, she argued that using randomness in machines and their ability to create a high number of outputs efficiently is actually can work to prove the opposite of that argument. Because when you work with a computer, you are using it as a tool to achieve more alignment with your imagination. You're using your creativity and your curiosity to create artwork, and you're using it in a medium that gives you more space for exploration than manual labor ever could. Over the years, Vera Molnar's methods and equipment for creating art kept evolving. In fact, as early as a decade before she even had access to a computer, she was already creating generative art. Because by definition, generative art is any practice where the artist uses a system, whether it's a natural set of language rules, a computer program, a machine, or any procedural invention, to run this system in some degree of autonomy and produce artwork. In the 50s, she introduced us to the term machine imaginaire, or the imaginary machine, and excuse my French accent, that's terrible. She used fundamental principles from mathematics and used analog randomness generators, like a roll of dice, to create artwork where she would divide a page into a grid, come up with some parameters, and with a roll of dice, adjust those parameters as she went on creating this artwork manually. After she gained access to computers, she initially worked with IBM computers, mainframe computers without monitors, and later on she transitions to more sophisticated machines, where she used like Fortran and BASIC as programming languages to feed instructions into the machine that would then control a pen plotter machine that would translate that code into artwork. All of this has truly fascinated me for multiple reasons. And the first one is personal. You see, I've always been passionate about drawing. And if you were to run into me as a child, you would see me carrying around a backpack with drawing papers and colored pencils and sitting in a corner somewhere trying to pour my imagination into the paper. At some point in my life, I accepted defeat and the fact that I am better with math and code than I am with manual skills. So you can imagine my joy when I later discovered that I can actually use code to draw, and I don't need to use my hands. And even better, to animate things. So I was really captivated by artwork such as Vera's and other artists of her time. This is actually from a colleague of hers from the same time period. And what fascinated me the most was their ability to use such limited technology to produce such amazing artwork for their time. Today, extraordinary work of arts related to generative art and animations are being produced with the amazing technology of our time. And Flutter, of course I'm going to mention it, not only art, it makes it makes for a great tool for building those artworks with cross-platform capabilities and out-of-the-box APIs. So, inspired by Vera's artistic style and ideas, we will explore Flutter's custom painter and the Canvas API, and we will do some animations with them. And I want to also share with you the thought process involved in creating such artwork from an empty canvas until the animated final outcome. We'll start by setting up our custom painter by simply returning a custom paint widget in the build method and providing it with a custom painter implementation. The custom painter implementation has two methods, a paint and a should repaint method. The paint method has the canvas, gives you access to the canvas so you can draw with it, and the should repaint method simply allows you to tell the custom paint to rebuild and rerun the paint method to update the canvas, which is useful especially for animations. We want to start simple. So we'll start by drawing a rectangle, simply by calling canvas.drawRect, and there are actually multiple ways from which you can create rectangles using the canvas. One of them is rect from center, and you simply give it a center parameter and the width and height, and the center is actually the center of the canvas. This would result in a simple rectangle. Another way you can draw rectangles is using from point, which is where you provide it with two diagonal points for the top left and top right bottom corners, and paint the rectangle. However, this will probably result in a rectangle that's not centered, and when it comes to rotating stuff or drawing things on the canvas from the center, it gets a bit tricky because generally the canvas is positioned in a location that is on the top left corner, and whatever you draw or rotate will be drawn or rotated respective to that point. So if you want to draw from the center, you would actually have to translate the canvas to the center point, draw whatever you want to draw, and make sure you call canvas.save before you do that, because that's the canvas's way of preserving the state of the multiple states of the canvas. And then you can call canvas.restore. The save and restore methods can be called multiple times, and they work as a stack where states of the canvas gets pushed and popped. So you can always do transforms and preserve the state of your canvas. Because actually, if you ever render any UI after you do transformations on the canvas, those transformations will be applied to it, even if they are children of the custom painter. So you need to call restore. And this is how like this we can center the rectangle. Now, there are a couple of tools that can be used when it comes to generative art, and I want to briefly mention some of the basic ones, and we can go through them and implement gradually a piece of artwork and see how that goes, and then animate it. We will start by tiling, which is where you tile stuff. And we can do that by, for example, calculating how many, the goal here is to repeat the rectangle that we drew. So we can do that by calculating how many rectangles would fit on the width and height of the canvas, and then we can draw it. I'm using here another method for drawing the rectangle, which is from left top width height, where you provided the left and top offsets and the width and height of the rectangle. Of course, again, this is not centered, so to center it, I'm using another method where I'm translating by calculating the offset of the whole grid minus the offset of the center of the canvas. And then, of course, calling restore. So we introduced tiling. We can now introduce recursion. What we could do is, instead of, we can do a loop to generate multiple rectangles and replace the rectangle drawing code with a recursive method that would keep drawing rectangles until we reach a specific width. And of course, this won't be work inspired by Vera Molnar if it didn't include what fascinated her the most, which is randomness. And to do that, we can actually, randomness is a very powerful tool that you can use it to create very amazing stuff. And sometimes actually accidental things come up and they would be amazing. And we can, for this case, we can introduce it in two ways. We can animate we can randomize the next width of the rectangle that we will recursively draw. And we can introduce a depth that would also randomize the size of the smallest one. So that was boring. We need colors. And actually, colors are interesting. Randomizing or implementing color in generative art is a bit interesting. Previously, when artists used to work with generative art, in the beginning, they used to work with pen plotters that didn't even have ink. And actually, Vera Molnar experimented with multiple weird stuff to implement colors, for example, blood and mud. But we don't have to do that now. When it comes to randomizing colors with code, you can actually go about it in multiple ways. The simplest way would be to create an array of colors and then randomly pick between them, but that would be boring also. So an alternative that might come to mind is randomizing the RGB values, which actually wouldn't work, because when you animate those values, you would get those like not so good-looking colors, darker and lighter, and you don't get the range that you would like. For that, you can use the hue and saturation and lightness properties of colors, and you can do that with the help of Flutter's HSL color from AHSL, where the A stands for the alpha, which is the brightness, and you can fixate the lightness and saturation to the point that you like, and then you can actually randomize the hue level, which will give you more randomization for colors without having to create a list. And now if we do that, things start to get interesting. And this is actually a lot similar to one of Vera's artworks. What you can also do is introduce a couple more parameters to your system. You can introduce parameters to change the fixed values that are not randomized, and you can experiment with them until you arrive at what you like. And using that would be like a powerful tool to get what you want to draw more aligned with what you imagined and expected in the beginning. This is actually similar to what generative artists used to do. For example, when I mentioned Vera's method of rolling a dice and picking numbers and selecting which things to draw based on that roll of dice, which was extremely excruciating, but she still managed to do that. Okay. Another tool of generative art would be displacement. Generative artists love to introduce chaos. A lot of orders don't make very beautiful things. So we can now do that. And to start, I'm going to draw this rectangle in another way, because the draw rect method only draws uniform rectangles and squares. So we're using the draw points, which is actually an efficient way to use drawing. And you have another alternative of draw row points, which will allow you to have more efficient drawing for like millions, and not millions, thousands of artwork in the same canvas. But we don't need that now. We can use the draw points and specify the point mode. We actually have a couple of choices. The polygon simply draws a line between each point you specify. And I'm going to simplify things by calculating already the top left, all the corners, and then introduce randomness by offsetting each of these corners with a random value around the origin. And you can actually set a maximum value that would, that when you experiment with, you can see the changes that are happening. This will later be very helpful when we move on to the whole artwork. Okay, now time for the last tool that we're going to use, which is repetition. And to do that, I'm going to randomize the number of polygons, let's name them polygons from now on, that are going to be generated. And this will allow us to produce a random number of polygons on top of each other. We can also experiment with that and see how the number changes the appearance of the polygons. And now I want to switch to dark mode because, of course, it's always better. And I want to introduce the tiling we talked about, and then the colors. And starting from a simple polygon or a simple uniform square, we arrived here. And now, it's finally time to the thing I do, which is animation. And we want to introduce that to our artwork. But before we do it, the code has already become so messy and so unreusable that I want to create some utility class to help me reuse and implement different getters and methods. For example, we can have the corners calculated and a list of points that we can then use. And this way, we can pre-generate the polygons instead of doing everything in the paint method of the custom painter. And also this way, we introduce the randomness from outside the custom painter, and this will help us later in the animation so that not every frame, the random number gets regenerated and the animation gets messed up. In the loop, we use the polygons that we introduced, and we can, for example, change the opacity of each of the polygons in the level, in the group, based on the level value. We can also save in that class the original points of the square, because later we can implement an offset.lerp method, which is a very useful functionality that allows you to have two offsets and provide it with a normalized value between 0 and 1. And this normalized value will tell it at which stage to render this offset. So instead of using points, I'm going to use that method and do a little twist with a sine function, because math, and this will do this. So we will get even more randomness, even more changes. And okay, now time to animate, for real. But first, I want to look at this and see what I can animate, and also based on the refactoring that I already did. And when I look at this, I can already see that I can animate the opacity to go from original to this state, and I can animate from square to polygon for each of them. But I don't want to do that at once. I want them to animate one after the other. To set up the animation, of course, we want an animation controller that we can provide from the widget and provide it to the custom painter's repaint method or repaint parameter from the super constructor. This is actually equivalent to calling should repaint in a different way, but it's easier to directly provide a listener that already updates and allow you to update the custom painter as the widget rebuilds. And now, because we don't want to animate all the polygons at once, we want to animate each one after the other. We can't use one simple animation that goes from 0 to 1. We want some kind of delay to be implemented. So we're going to create a list of animation objects that will have the same length of the polygons. And we will use a tween with the begin and end values that we can choose and connect it to the animation controller and choose a a curve that would make sure the animation is not just linear, it has some effect. And the animation start and end values we can already calculate simply by the level, for example, and make them consecutive. And we can do that, we can use that in the color of the paint and in the, yes, and then we have this. So, yay. Thank you. Of course, we need the tiling, so we commit to the tools that we introduced. And we can also not animate them all at once. We can also introduce another level of delay, which is the location of the tiles. And this would make it go from left to right. We can also and we can also experiment with all of these values to our liking. I always like to imagine myself doing that with the dice because, of course, it's much more fun, even if it's very tiring. But I like to do difficult things. So that was Flutter. And Flutter is a mobile application or an application framework, and it won't be much interesting without introducing this to user interfaces. So when we talk about generative art, we only imagine artwork that we see. And what I like to do is similar to how Vera Molnar's artists from her time used to use machines to transform this code from a digital medium into the physical medium of the paper with pen plotters. I think it's a very good idea to transform this digital form into the hands of regular application users. And I think mobile applications would really be improved by using this, because we now have very, very sophisticated technology. We don't have to use dice to do this. And the number of applications that are actually very, very unique and impressive are not that common. And I think this should not be the case because we have a lot of powerful tools at our hands. And it would be really better to have to integrate user interfaces into the field of generative art. A simple example is to introduce images to create a gallery, for example, and to do that you can also use the canvas to draw an image. And we can use the path of the points that the path of the polygons that we created to create clipping around those images. And to do that, we can simply call the clip path method of the canvas and provide it with a path. The path is simply an object that can have methods like move to, line to, close, and reset. It's very similar to every canvas technology you can think of. And we can use the path of the polygons to generate the points of the polygons to generate that path and clip before drawing the image. But we also need to call save and restore, otherwise we won't get the clipping that we required. This could generate something like this. And this is the beginning of what we can create with generative art and Flutter. And this introduces the question of, can user interfaces actually be art? And I think they can. I think using art to incorporating art in our everyday things will like naturally introduce beauty in our lives, and we can't say no to that. And even if we don't feel it or don't want it, it will improve our lives. And yeah, that's my goal for this. So thank you.